The stars above me are closing in, so water roll me home.
D-2 Inc. Oceanography News.
Day will come, but not as long.
Our Earth is covered mostly by ocean, which is governed by a series of interconnected currents. What if I told you one of the most major currents, the AMOC, was on the verge of potential total collapse? Welcome to D2 Oceanography News, Episode 3, and today's main story is the weakening of the Atlantic Meridional overturning circulation driven by subarctic freshening since the mid-20th century, and the potential for a total AMOC collapse as discussed in new research that has come out. Important new study shows that current climate models underestimate the human-caused slowing of the AMOC, Atlantic Meridional overturning circulation, because they neglect freshwater influx from Greenland melt and other sources. WTF is the AMOC? It's the Atlantic Meridional overturning circulation, which is a fancy name for an important ocean current that effectively serves as a heat pump for Earth, bringing warm surface water from the tropics northward, releasing its heat, sinking, then bringing deeper cold water back south.
The Atlantic Meridional Overturning Circulation, or AMOC, is a system of ocean currents that forms a vertical loop that spans the whole length of the Atlantic Ocean. Every second, it moves an incredible 17 million cubic meters of warm water north along the ocean surface, returning cold water south through the ocean depths. This distributes 1.2 million petawatts of heat, equivalent to the energy flowing through 1 million power stations.
So this paper came out on the AMOC weakening, and its abstract says, the AMOC is the main driver of northward heat transport in the Atlantic Ocean today, setting global climate patterns. Whether global warming has affected the strength of this overturning circulation over the past century is still debated. Observational studies suggest that there has been persistent weakening since the mid-20th century, whereas climate models systemically simulate a stable circulation. Here, using Earth system and eddy-permitting coupled ocean sea ice models, we show that a freshening of the subarctic Atlantic Ocean and weakening of the overturning circulation increase the temperature and salinity of the South Atlantic on a decadal timescale through the propagation of Kelvin and Rossby waves. We also show the accounting for upper-end meltwater input in historical simulations significantly proves the data model agreement on past changes in the Atlantic Meridional overturning circulation, yielding a slowdown of 0.46 sverdrups per decade since the 1950. Including estimates of subarctic meltwater input for the coming century suggests that this circulation could be 33% weaker than its anthropogenically unperturbed state under 2 degrees centigrade of global warming, which could be reached over the coming decade. Such a weakening of the overturning circulation would substantially affect the climate and all ecosystems.
Ocean temperatures keep setting all-time highs. But in the North Atlantic lies one very mysterious, very creepy exception. It's called the Cold Blob, or the warming hole. And according to climate models, it shouldn't exist today.
So this study shows that accounting for upper-ender meltwater input in historical simulations significantly improves the data model agreement on past changes in the AMOC circulation, yielding a slowdown of 0.46 sverdrups per decade since 1950. Professor Stefan Ramstorff continues to state, in our 2018 Nature article, we estimated around 3 SV slowdown since 1950, an example minus 0.4 SV a decade, based on the observed cold blob in the Atlantic west of Britain. We must expect a faster AMOC decline than IPCC has predicted. It is very likely, 90 to 100% probability, that the AMOC will weaken faster than the CMIP6 projections if meltwater forcing is considered. That's bad news. It increases the risk of passing what's known as a AMOC tipping point, or the collapse of the AMOC itself.
Remember the cold blob that climate models say shouldn't exist? Well, it's there today because so much ice is melting in Greenland. That melted ice winds up in the North Atlantic and makes the ocean less salty. And that salt is what drives the northern leg of the AMOC. Lighter, fresher water doesn't sink. It floats, blocking the overturning current and cooling the surface temperature.
How much is the AMOC weakening? Numerous studies show that the AMOC is indeed weakening substantially, more than even the latest climate models expected, and that it's at its weakest state in the last 1,600 years. And this is why we need more data to be sure so that we can have a better understanding of what is happening in the ocean. This is why D-2 Inc. now offers a line of CTDs that is able to provide extremely accurate salinity and temperature data for these types of studies of the AMOC. We even have CTDs perfectly designed to fit on ITPs, ice tethered profilers, or tethered ocean profilers, which are able to drill down through the ice and measure the interface of ocean water underneath these glaciers. The perfect device for measuring if ocean water is affecting glacial melt. You can see the model here for how the AMOC has changed over time, and you can historically see what that has done, causing ice ages or mini ice ages when its strength dramatically increases due to one of these tipping points. One of the main worries is all of this fresh water that is melting from the glaciers in Greenland is going to cause the tipping point to happen faster in the AMOC. As Greenland melts faster and faster, it's even experiencing rain on the summit of the Greenland ice dome. The Greenland ice sheet has the shape of a dome, with the summit resting at the very top. The ice dome is so immense that it's hard to picture. Even if you've flown across it, it extends over more than 650,000 square miles, an area roughly the size of Alaska, and in the middle it is 2 miles tall. It is massive enough to depress the Earth's crust and to exert a significant gravitational pull on the oceans. If all Greenland's ice were cut into 1-inch cubes, and those were piled one on top of another, the stack would reach Alpha Centauri. If it melted, a rather more plausible scenario, global sea levels would rise by 20 feet. Until relatively recently, it was thought the summit would be, if not unaffected by climate change, at least untroubled by it. Such is the ice sheet's bulk that at its center it creates its own weather. But in the past few decades, Greenland has changed in ways that have stunned scientists who spend their lives studying it. Since the 1970s, it has shed some 6 trillion tons of ice, and the rate of loss has been accelerating. Crevices are appearing at higher elevations, glaciers are moving at non-glacial speeds, and large parts of ice sheet appear to be twisting, like a writhing beast. In July 2012, surface melt was detected at summit for the first time since modern measurements began. In 2019, the station experienced melt in mid-June, and then again in late July. On August 14, 2021, it rained, an event so remarkable that it made news around the world. For the first time on record, rain fell on the summit of Greenland, ran the headline in the Sydney Morning Herald. There was late season melt at the summit in September 2022 and more melt in June 2023.
So researcher Mohammed Azat decided to see if that cold blob existed during the last interglacial because he wanted to understand the consequences.
We found a warming hole during the last interglacial period. And this has very important implications for our understanding of the sensitivity of the system.
He analyzed marine sediment from the ocean floor to understand the salinity and temperature of the northern Atlantic during the last interglacial.
We found significant cooling associated with freshening and slowing down of the deep water formation in the Nordic seas. Warming climate and subsequent melting of ice could slow down the Atlantic Meridional overturning circulation.
One of the other tipping points might be what's known as the Beaufort Gyre, which is a circulating current in the Arctic that has been stabilizing and accumulating more and more fresh water. The worry is that a large amount of fresh water might be released at once, which would flow down into the AMOC and shut down the AMOC. So why is the Beaufort Gyre collecting more and more fresh water? Well, because there's more and more fresh water being deposited into it by all the melting ice in the Arctic. As you can see from satellite imagery from 1990 until almost the current year, over the past 20-something years, the Arctic has been slowly declining in the amount of ice that's there, to the point where there is almost none of the oldest ice left at this point. The Beaufort Gyre is an extremely powerful current. The satellite imagery, you can see the cracks that it creates in the Arctic ice by flowing underneath it. First observational evidence of Beaufort Gyre stabilization, which could be precursor to huge freshwater release, a story out of Woods Hole Oceanographic Institution. A new study out of Woods Hole, Mass. provides the first observational evidence of the stabilization of the anticyclonic Beaufort Gyre, which is the dominant circulation of the Canada Basin and the largest freshwater reservoir in the Arctic Ocean. The study uses newly extended record of dynamic ocean topography satellite data from 2011 to 2019 provided by two of the co-authors, along with an extensive hydrographic data set from 2003 to 2019 to quantify the changing sea surface height of the gyre in recent years. Previous observations and modeling that relied on earlier dynamic ocean topography data up to 2014 have documented that the gyre has strengthened and increased its freshwater content by 40% compared with 1970s climatology. Stabilization of the gyre could be a precursor of a huge freshwater release, which could have significant ramifications, including impacting the Atlantic Meridional Overturning Circulation, AMOC, a key component of global climate. The Beaufort Gyre has transitioned to a quasi-stable state in which the increase in sea surface height of the gyre has slowed and freshwater content has plateaued. In addition, the cold halocline layer, which isolates the warm, salty Atlantic water at depth, has thinned significantly due to less input of cold and salty water stemming from the Pacific Ocean, and the Chukchi Sea Shelf, together with greater entrainment of lighter water from the eastern Beaufort Sea. This recent transition of the Beaufort Gyre is associated with a southeastward shift in its location as a result of variation in the regional wind forcing, according to the journal article Recent State Transition of the Arctic Ocean's Beaufort Gyre, published in Nature Geoscience. You can see them collecting measurements in the ice in the western Arctic Ocean with a traditional rosette, which would include a CTD, which you can now use a D-2 ink CTD for. As the ocean water warms underneath the Antarctic ice sheet, because the AMOC is sending less and less cold water south, this causes the Antarctic ice sheet to continue to melt and reach a tipping point, as the water underneath the ice is now melting the ice from below. And this is another one of these massive things that you can use the CTD to measure as you drill down through the ice to measure the interface of the glacial water and the seawater. Next up from @Oceanography, we have footage from the Mariana Trench, 10,792 meters down, which is how far our sensors can go, even further than that actually, 11,500 meters down. And this here is the footage of the trench. Enjoy. Another story out of Woods Hole Oceanographic Institution. is regarding the Pilgrim nuclear plan to discharge its radioactive wastewater into the Cape Cod Bay. WHOI's Mariana Rapina released a study that shows how long it would persist. One of the findings from the study is that this radioactive wastewater discharged from Pilgrim would move near Cape Cod coastline. New research on water circulation in Cape Cod Bay shows that if radioactive wastewater were discharged from the Pilgrim nuclear power station, it would likely remain in the bay for at least a month. The researchers used a high-resolution model of ocean circulation developed by the National Oceanic and Atmospheric Administration, NOAA for short. They found the probability of wastewater particles leaving the bay within 3 weeks is only 12% in spring and summer, and even lower in fall and winter. Even in spring and summer, the bulk of the wastewater is much more likely to stay in the bay, said one of the study authors, physical oceanographer Mariana Rapina of Woods Hole Oceanographic Institution. It is unlikely that the wastewater would leave the bay over those timescales, she said. The study seeks in part to address public concerns about the fate of radioactive material and reactor system at water at Pilgrim. Pilgrim owner Holtec International has proposed discharging the water into Cape Cod Bay as part of the plant decommissioning. The Pilgrim reactor was shut down in 2019. The water that remains, more than 900,000 gallons, would be treated and diluted, but treatment does not remove all contamination, including some of the radioactive isotopes. As the water moves through the bay, the particles it transports would very likely move close to the coastline, including Dennis, Wellfleet, Provincetown, Rapina said, and particles that leave the bay would be pushed by currents around the tip of the cape. An interesting story out of Woods Hole Oceanographic. What can hydrothermal vents tell us about life on other planets? A new WHOI-led study of vent systems in the frigid Arctic shows these hotspots of deep-sea marine life are more chemically diverse than previously thought. Chris German, a WHOI senior scientist and principal investigator for NASA, Exploring Ocean Worlds project, says this new information will aid in the search for life on other worlds' oceans. A 120-degree C vent is sampled using a robotic arm. Scientists dubbed it Lander, related to a NASA Europa mission concept study. By studying hydrothermal vent fields such as Aurora, scientists hope to also learn more about Saturn's moon Enceladus. Black smoker vents, such as this one at Aurora, discharge fluids up to 370 degrees C. Scientists recovered the robotic submersible Nereid under ice, almost 4,000 meters above Aurora. They believe that these Arctic hydrothermal vents may resemble those on Enceladus. They likely share another striking feature. For a decade, scientists have inferred the presence of hydrogen-rich hydrothermal vents on Enceladus, which may inject its seas with ingredients for primitive life, and they have now located 3 such vent sites, possible proxies for those on Enceladus beneath Earth's Arctic Ocean. Last year, a NASA-funded international team deployed an uncrewed submersible into the Arctic waters near the North Pole. The researchers explored a vent field dubbed Lucky B, the third they thoroughly explored. All 3 sites, out of the 10 known to exist on the Arctic sea floor, release plentiful molecular hydrogen and methane, but their chemical recipes are surprisingly distinct, according to marine geochemist Chris German of Woods Hole Oceanographic Institution. Quote, "We thought there was a good chance that somewhere in the Arctic we could find hydrogen-rich vents, but now we're 3 for 3, said German, who reported the team's research on 11 December at AGU's annual meeting 2024 in Washington, D.C. Turns out there are lots of different ways to get hydrogen-rich venting in these Arctic geological settings. That's encouraging if you want these vents to also be present in space." Ocean itself is also its own alien world, and in these photos by Larry Madine from Woods Hole Oceanographic Institution, you'll see what I'm saying. These are some incredible pictures of jellyfish from the ocean twilight zone. These jellyfish have adapted to produce their own light to camouflage, to scare off predators, and even attract prey. Enjoy. Ocean Power Technologies, the power buoy for the Naval Postgraduate School, is fully assembled and ready for deployment in early 2025, featuring AT&T 5G advanced subsea sensors and our AI-capable MDA solution, Meros, set to deliver autonomous low-carbon maritime monitoring. Interesting information. Ocean Power's technology has announced the power buoy for the Naval Postgraduate School. The full system includes installing AT&T 5G tech and integrating advanced subsea sensors into a power buoy equipped with OPT's latest Meros suite for AI-capable seamless integration of maritime domain awareness, MDA, across platforms. It's now being readied for shipment, ready for deployment early 2025, alongside Technology Showcase NPS is hosting in January. Once deployed, the power buoy will provide continuous, autonomous monitoring and data collection capabilities in one of the world's most strategically significant maritime environments. It's another step forward in executing the company's robust strategic plan. And a part of that plan should be including D-2 CTDs on these power buoys. Story from Christopher Vo, who's working with autonomy and AI, unmanned systems at Saab. Over the past week, Saab and Purdue University team had a great time testing for the Defense Advanced Research Projects Agency, DARPA, learning introspective control link program, developing advanced vehicle control algorithms to enhance human capabilities in operating surface vessels. Link is designed to empower both experienced and novice operators with near superhuman capabilities to handle unexpected conditions, adapt to change, and recover from damage, enabling them to safely maneuver in the most challenging maritime, coastal, and riverine environments. Hashtag keeping people and society safe. This week we successfully demonstrated a link-assisted docking maneuver with the Small Ocean Power Technologies, hashtag WAMV, hashtag USV. With guidance from the link system, an unskilled human operator used a joystick to safely dock the vessel into a slip. Make sure to head over to d2.com and bookmark it to stay up to date on all the latest news on our D2 news page. Thanks for watching out there, everyone. Make sure to like, share, and subscribe here on YouTube, and follow us on Twitter and on LinkedIn.